Now, first of all, the trend is opposite of ionization energy, so this will go to now 3p6, and so now we'll have, on level 3, we'll have 8 electrons. In this video, we're talking about atomic radius, and this one makes a lot of sense. Radius is what you think. It's the size of an atom. So let's get into the trend. Now, first of all, the trend is opposite of ionization energy, which is what we just learned. So as we go to the right across a period, radius of an atom actually gets a little bit smaller, and I'll explain why. As we go to the right, the effective nuclear charge is increasing as you go to the right. And so that increasing positive charge in that nucleus is going to pull that electron in a little bit tighter, and so the radius will actually decrease as we go to the right across a period. Now, as we go down a group, the atomic radius increase, and this makes total sense because every time we go down a period, we are adding a whole new energy level. For example, from lithium to sodium, we go from 2s to 3s, and so they get physically larger every time we add an energy level. So in this case, the sodium would be larger than lithium. Now, sodium versus magnesium, remember, as we go to the right, effective nuclear charge increases, so the radius decreases. So sodium is larger. Now, let's look at atoms and ions. What happens to the radius when an atom gives or takes electrons and forms an ion? Well, let's look at an example of sodium here. I've got a little illustration, and I'm going to just draw in the number of electrons. So the first energy level, I have 2, and then I have 8, and then I have 1 valence. And what happens with the sodium atom? What leaves? What valence electron is removed? I'm going to lose 1 valence. I like to abbreviate VE for valence electron. Which one goes? This one goes. That one goes. And what happens when you lose that electron? Now look what we have. Something much smaller. Now we have the sodium ion. And I know that the sodium ion is smaller than the sodium atom. Why? That valence electron that we lost was a complete in a completely different energy level. So now it's physically smaller. Now here is sulfur. Let's do this example. Sulfur has 2 electrons in the first level, then we have 8, and then I have 6 out here. Now to go from the sulfur atom to an anion, we're going to gain 2 electrons. Okay, so where are they going to go? Well, there's room right there in that those p orbitals. So this will go to now 3p6, and so now we'll have, on level 3, we'll have 8 electrons. Well, did this get any larger? Well, we didn't add it to another energy level. However, now we have 6 electrons crammed into these p orbitals. And the more electrons in those orbitals, remember, electrons are negative, they're going to repel each other. So those orbitals physically get a little bit larger because there are so many electrons in there. So sulfide, that anion is slightly larger than the sulfur atom. So cations, I did this backwards. No, I did that right. Cations are smaller than their atoms, and anions are larger than their atoms. Let's look at one more trend question that you might see something like this on an exam. Arrange these atoms in order of increasing radius. So what you're going to do, now I have 3 and I can't just compare 2, so I'm going to take my periodic table and physically I like to touch them with my fingers and I'll locate them. So beryllium is here, barium is way down here, and fluorine is in the same period as beryllium. So let's see, which one is the biggest by far? Well, what catches my eye is barium. He's several periods down, and so I know barium is the largest. So I'm going to put him right there on the end. Now, which one is bigger, beryllium or fluorine? What is our trend as we go to the right? Radius increases. I'm sorry, it decreases. Why? Effective nuclear charge is pulling those valence electrons in slightly as we go to the right. And so if radius decreases, that means fluorine, he's the smallest, and beryllium is right there. So that is the order of increasing radius. And the only way to do it is to locate elements on the periodic table and remember the trends.